So this is a sample practice problem 1.63 from the MOTS textbook. The question is, a measure of stiffness of a linear actuator system is the amount of force required to cause a certain linear deflection. For an actuator that has an ID, or inside diameter of 0.5 inches, and a length of 42 inches, and that is filled with a machine oil, compute the stiffness in pounds per inch. So what does that mean? So I've drawn a free body diagram here, but basically stiffness, you can think of stiffness as a spring. So basically it's force over the displacement caused by force the displacement caused by the applied force. So I've just drawn a bit of a diagram here. So we have an ID of 0.5 inches. That should be inches. It's 42 inches long. And from the MOTS textbook, we know that the bulk modulus of a material, of a liquid, is equal to the negative change in pressure over the change in volume divided by the original volume. So the BM for machine oil is equal to 189,000 pounds per inches squared. 189,000 pounds per inches squared. Okay? So that's what this term is going to equal here. So knowing stiffness is equal to force over displacement caused by the applied force, let's just sort of break down this equation. So in the case of this linear actuator, what is delta V over V? Okay, so delta V is really, in this actuator, is really going to be the change in length. So if you think about it, the volume here is going to be pi d squared over 4 times the change in length over pi d squared, or id, over 4 over L. Okay, well what can we cross out here? We can definitely cross the pi's out, we can definitely cross the d squareds out, and we can definitely cross the 4's out. So basically, delta V over V is equal to delta L over L. Okay, so let's sub that back into this equation here. So BM is equal to negative delta P over delta L over L. Okay, where L, this term here, is 42 inches. Okay, so I'm still not seeing where we can go with this, but let's just keep digging down here. So if you think about it for a second, the BM, the negative delta, what does P equal to? Well, P is equal to force over area. Okay, and that's one of the terms we're looking for up here, right? Is force. So that's interesting. We happen to know the area because the area is equal to the ID, the pi d squared over 4 of the, where d is equal to 0.5 inches. So if we sub this into here, we're going to get BM equals delta, really it's delta F over A, because A is constant in this case, over delta L over L. Okay, so remember, we want the force over the displacement caused by that force. So if we keep going here, so basically this is equal to F over A, this term here, times the L comes up top over delta L. Okay, so this is what we want here. Okay, so BM, so basically we need to isolate the F over delta L by moving the A and the L over here. So if I multiply this side by A, and then this side also by 1 over L, basically I have to do the same over here, right? I have to multiply by A, bracket 1 over L. I do the same, So then this crosses out with this crosses out with this, and we're left with F over delta L is equal to A over L times the bulk modulus. And let's just put that's pi d squared over 4 over L times the bulk modulus, which is equal to pi 0.5 inches squared over 42 inches times 189,000 pounds per inches squared. Now let's take our units here. So the inches squared crosses out here, and you're left with pounds per inch, which is what we want, force over displacement caused by that force. So if you multiply, if you multiply this out, you get 883.57 pounds per inch, which would give you the stiffness of the linear actuator filled with a machine oil.